Hey guys, we've been working pretty good. Most of you are doing pretty good on multiplying polynomials, etc. Now we're going to start dividing a little bit. Okay, we're going to do the easy part first, just to get you used to what's going on. But as you can see here, it says we're going to use the distributive property. We're going to kind of use the opposite of the distributive property. Okay, when we do what's called factoring. Okay, you know, if I said what are the factors of 6, you would say, well, 1 times 6 and 2 times 3. Basically, we divided 6 by 1, or we divided it by 3 and got 2, etc., right? That's what we're doing. Those are the factors, okay? And so we're not going to do these two things just yet. We're going to do those later, but for right now, we're just going to focus on factoring out like terms, okay? And so we got to figure out what those things are. So let's just start with a review of distribution. If we had something like this, you would take the 2 times both of these things, right? And you get 4x plus 10, right? Or if we had, say, 3x, and we did this in the last 2x minus 7, we would get 6x squared minus 21x, right? We did this kind of multiplication in the last 2 tries that we've done, the last 2 things we've done online here. Okay, but that's just the distribution property, right? Okay, so now we're going to do the opposite. We're going to go from this back to that, or this back to that. We're going to go the opposite direction. Okay, so how do you do that? Well, what we do is we look at this 4x plus 10 and we say, well, what goes into both of those things? What are the common factors? Well, 2 goes into 4. Does 2 go into 10? Yeah. I guess we probably should have tried the biggest one first, 4. Does 4 go into 10? No. Okay, and the biggest factor of 10 is 5, and it doesn't go into 4. Okay, you want to do that first. You want to always try to find the biggest one first. And so 2 works. However, there's also an x there. Can I pull an x out of both terms? No, because 10 does not have an x. So the only thing I can pull out is a 2. And so what we do is we say, all right, I'm going to have a 2, and then I'm going to have 2 times something. So then what I do is I'm just going to divide each of these things by 2. So 4x divided by 2, well, that's 2x. And then I'm going to divide the 10 by 2. Well, 10 divided by 2 is 5. And I look up here, and it should be a positive. And if you'll notice, we ended up with exactly the same thing that we started with before, didn't we? Okay, so let's do another one like that before we come back and do this guy. It's coincidence that it was almost the same numbers. Let's say I got 6x minus 15. Okay, so the biggest factor of 6 is 6. Can I pull a 6 out of 15? No. The biggest factor of 15 is 15 or 5, and I can't pull either one of those out of 6. But does 3 go into both of those things? Yes. Okay. Now, what's left if I pull out a 3? Well, 6x divided by 3 is 2x. Oh, that's nice. And then divide this one by 3, and 15 divided by 3 is 5. And so it's got to be a minus, since this is minus right here. Okay, now that, but, okay, so then this would be my answer. I factored 6x minus 15 into this. If I distributed this, 3 times that and 3 times that, I'd get what I started with, 6x minus 15. All right? That's what's going on there. We can do another one. Let's do one more. Let's say I got 12x plus 24. Okay, this time I'm looking for the biggest factor of 12. It's 12. Does 12 go into 24? Yes, it does. So I can put a 12 right here. And we can say, all right, I got to divide by 12. So 12x divided by 12 is just going to be 1x. or x, I could say, plus, because there's a plus sign here, and then 24 divided by 12 is 2. So now if I redistribute it there, 12x plus 24, there's my original statement. So we factored it into this. Now the thing you want to be careful of is, this is why you want to pull the biggest one out. If this is still factorable, sometimes there'll be, something that you can pull out of that still. So if that's the case, this number wasn't big enough. Okay. Let's go back to that one. I don't even remember what it was now. I don't like going back because I don't think I get everything in there. Let's say it was this here. Okay, and we're going to factor that. So what's in common here? Well, does 6 go into 21? Nope. And the biggest factor of 21 is 7, and it doesn't go into 6. So what about 3? Does 3 go into both? Okay. Now, there's also something else that they both have. What do they both have? They both have this variable x. Even though they're not the same exponent, there's still at least one x in both things. Okay? And so I can pull that out. I can factor that piece out. But I'm just going to divide by the thing that I pulled out. So 6x squared over 3x. Now we got to go back to our ideas about our exponent operations and our properties that we had. Okay, we're going to subtract our exponents here, aren't we? So 6 divided by 3 is 2, and then x squared over x to the first is just going to be 2x, isn't it? So, I'm sorry, just x, but I got the 2 in there from the 6 and the 3. And then if we go 21x divided by 3x, now, in this case, our x's will cancel, won't they? And so we just have a 7. Now, again, if I look at this, if I distribute this times this, 3x times 2x is going to give me the 6x squared, and 3x times 7 gives me the 21x. And so we factored this. Now, again, I'm going to look at this parentheses, and there's nothing that goes into both of those to make this smaller. So it's factored as far as it can go. Okay, let's try one more of those. Let's say we got 4x squared minus 18x. Okay, so I'm looking at the factors of 4, 1, 2, and 4. And the factors of 18, 1, 2, 3, 6, 9, 18. Well, the biggest one they have in common there, and that's really all we're doing is finding factors, is 2. So I can pull out a 2 now. Do they have a variable in common? Yes, they have 1x. Okay, so now if I divide everything there by 2x, 4x squared over 2x, 4 divided by 2 is 2, and then x squared over x is x. Then I got a minus sign, and then I got to take 18x divided by 2x. That's going to cancel, and 18 divided by 2 is 9. And again, look at this guy. Is there anything in common in 2 and 9? No. So I'm done. Now, sometimes there's going to be more than just this number of x's. Okay, there might be something like this here. You might have like 6x to the 5th minus 9x to the 3rd. So in this case, I can only pull out the smallest number of x's. Just like before, when there was only 1x, I could only pull out 1x. Now I can only pull out 3 x's. Okay? So I'm going to have an x cubed as one of my common denominators. But what else here? What about the 6? 1, 2, 3, 6, 1, 3, 9. The greatest common factor is 3. Okay, here 3 is in common there. Okay, so I can pull out a 3x cubed. So if I divide by 3x cubed, what's left here? Well, 6 divided by 3 is 2. I love 2. I don't know why it's always 2. And then 5 minus 3 is x squared. X to the 5th over x to the 3rd is x squared. So that's 2x squared. Then we got a minus sign. Now, 9x cubed over 3x cubed. Well, again, the x cubes cancel, and 9 divided by 3 is 3. Now, I look here. Is there anything in common? Nope. So I'm done. And I can check this way, too. This times this is going to give me that 6x to the 5th. And this times this is going to give me this. Okay? And that's really all we're doing there. You can do it with more than one variable too. Okay, we'll do a couple examples there on the note sheet. So let's go to the page here. And so they've got 15x plus 25x squared. So what's the greatest common factor? Looks like 5 to me, and an x, because this guy's got an x. Okay, so they pull that out. They said, all right, here's their greatest common factor. And then they divided each thing by that 5x. And so I don't know why they put this huge sign there like that, but this here would cancel, and 15 divided by 5 is 3. And then 25 divided by 5 is 5. And then we still have x squared over x would give me an x. And so then they put them back together. I don't necessarily like the way they did this here, but it's the same thing we've been doing. The answer ends up the same. Okay? All right, let's try this one here on a different sheet because it's really screwy looking the way that they did this. All right, let's see here. So we got 12xy. Oh, I changed my size. Plus 24xy squared minus 30x squared y to the fourth. Oh boy, look at this mess. All right, so the smallest numbers of x's and y's is all I can pull out. So this guy only has one of each. So I can only pull out one out of all three of them. I can only pull one thing out. Okay? So I can pull out an x and I can pull out a y. And that's all I can pull out for the x's and y's. Now let's look at our numbers, 12 and 24 and 30. What goes into all those things? Does 6 times 2, 6 times 4, and 6 times 5, right? Is there anything bigger? 12 would go into 24, but does 12 go into 30? No, so I can't use 12. So I think we're good. I think 6 is the number. So that's what we're pulling out. Now we've got to figure out what's left. And we're going to have 3 terms because we're going to divide each of these by 6xy. And notice my signs are the same. There's a plus there and a minus there, so I got to have a plus and a minus. And I'm going to erase that. Okay, so now let's go back right here. What's going to happen to my x and y's? Well, they are going to cancel. And then 12 divided by 6 is 2. Now on this one, my x's cancel, and then y squared over y is just going to be a single y, and then 24 over 6 is going to be a 4. Now this one, only one of my x's will cancel. Okay, x squared over x is going to be x, and y to the fourth over y is going to be y cubed. I'm going to make this a little bit bigger so I have a little bit more room. So I got xy cubed, and then 30 divided by 6 is going to be 5. This is my answer. You'll notice that there's no letters in common in all of them. Okay, there's a y here and a y here, but there's no y here. And there's no x in either of these. I'm sorry. There's a y here and a y here, but there's no y here, so there's nothing in common there. And then this guy has an x, but these two don't. And 2 will go into 4, but 2 or 4 don't go into 5. So this is factored completely. So this is our answer. All right. And I think they showed, oh, look at that. They got the same answer we did. We did it right. Okay. They do it a little bit differently, but they're really breaking down each number is all they're really doing there. Just remember that you can only pull out the smallest number of the variables. So the smallest exponent of the variables, and then the largest number that you can pull out. All right, so we'll do another one here. All right, so I'm going to rewrite this for you. You got 3x squared y plus 12xy squared. Well, How many x's can I pull out? The smallest number of x's is a single one, so I can only pull out one x. And the same thing with the y's. I got a squared over here, but I've only got one here. So I can only pull out one x and one y. Now I'm looking at my 3 and my 12. 3 goes into 12, so 3 is what I'm pulling out. Now we divide each term by that common factor. So 3xy and 3xy. So here the y's would cancel, right? And the 3's would cancel. And then x squared over x is x. And on this one, the x's cancel. And so 12 divided by 3 is 4. And y squared over y is y. And there is your answer. Okay. All right, I think there's one more. I'll let you try it. Yeah, I'm going to rewrite it for you. But it's 3ab squared plus 15a squared b squared plus 27ab cubed. Okay. Give that a try. I'm pretty certain that this one is your answer. 3ab squared and then 1 plus 5a plus 9b. See if you can get that. I will post a quick check later today. There won't be any as involved as this, but this would be a good practice for you to see if you can get it. It'll be due probably on Friday. So let me know if you have questions. Keep working hard. You're doing a good job.